Hey guys, Mr. Smith here, shooting a little quick hits video on evaluating limits that are indeterminate. In this video, I'm going to review our three strategies for doing that. For our first one, if you notice, if you plug in 2, you get on the top, you get 8 minus 6 minus 2, 0, and on the bottom, 2 minus 2, you get 0. 0 over 0. But this limit actually exists. And so one strategy we have for evaluating limits like this is to, if it's a polynomial, or if it's quadratic, is to factor. And we're going to factor this guy. It is a complex trinomial. I'm going to factor it off to the side here. So 2x squared. We're looking for numbers that add to minus 3, multiply to minus 4. Those numbers are minus 4 and positive 1. Minus 4x plus x minus 2. Common factor each pair. And the last pair, there is no common factor. I can just take out a 1. I kind of like writing the 1. X minus 2, and we're left with 2x plus 1. So heading back to my problem, we can see that after factoring, we have a factor of x minus 2 on top and now on the bottom, which means we can divide it out. And we're left with something that we can plug x equals 2 into. This is not indeterminate. I can plug 2 into there. 2 times 2 plus 1, that's equal to 5. So factor first. You never know. Maybe you'll have a factor on the top and bottom divide out. Our second method was called rationalizing. Now, if you look at this expression involving radicals, if you plug 0 into the top, the root of 1 is 1. 1 minus 1 is 0. And the bottom, plugging in 0 gives you 0. Again, this is of indeterminate form. What we do is we multiply by the conjugate. So the conjugate of the top, it's just the same two terms with an opposite sign, like that. And to make sure we don't change the expression, we have to multiply by the same thing on the bottom. So it's like we're multiplying by 1. The conjugate of some expression a plus b is a minus b, and conversely, the conjugate of a minus b is a plus b. This is what it means for two things to be conjugates. All right, let's continue. So why do we do that? Well, the big idea is that when you that is actually a difference of squares, and when you do the 4 multiplications, the root of 1 minus x times the root of 1 minus x is equal to 1 minus x. Negative 1 times 1 is negative 1. And that's it, because there's 2 cross terms. The root of 1 minus x times 1 and negative 1 times the root of 1 minus x give you pairs that are the same but different signs. And so they add to 0. On the bottom, no fancy simplifying we can do. We just have x times the root of 1 minus x plus 1. And the beauty of this is, on the top, we get a 1 minus 1, and we're left with just negative x. And common theme, we get some canceling on the top and bottom. X divided by x, negative 1 over, forgot my limit. I'm sure you guys will have moments where you forget to carry your limit down as well, but we need to carry it down all the way until we substitute in. So negative 1 over the root of 1 minus x plus 1. Now we can plug in 0. Negative 1 over the root of 1 minus 0 plus 1. So on the bottom, we have the root of 1 plus 1, which is 2. And I'll just squeeze this in here. This is equal to negative 1 over 2. In the case of if you have a radical expression, rationalizing can help you. Thirdly, if you look at this example here, we cannot factor. There is no, this is that trick we used earlier won't work with this by multiplying by the conjugate, because it's not a root, just a plain old square root. It's the 4th root of x, and the 4th root of x, since the 4th root of x is actually the root of x, and like we don't get anything kind of canceling. So our strategy with these last kinds of problems is to, or like a last resort, is to use substitution. And so instead of working with the fourth root of x, I'd rather not work with the fourth root of x. So I'm just going to replace the fourth root of x with a variable u. So it's worth asking, in the top I have an x. Well, if I'm replacing the fourth root of x with u, what do I replace x with? Well, it's not too hard to visualize that. If you square u equals the fourth root of x, well, if u is the fourth root of x, then u to the power 4 would be equal to x. That's just how roots work. And the last thing we have to do is, because the original limit was in terms of x and we're introducing this new variable u, we have to ask ourselves, what happens as x approaches 16? What happens to u? Well, u will approach the fourth root of 16, which is equal to 2. And what we can do is, we've now converted this limit into a new variable. The limit is u approaches 2. On the top, we have u to the power 4 minus 16. All over on the bottom, u minus 2. And now we can apply a strategy from earlier. We can factor this. You can actually factor the top as a difference of squares, as u squared minus 4, u squared plus 4. And u squared minus 4 is actually a difference of squares too. I can factor that as u minus 2, u plus 2. Of course, I still have u squared plus 4 all over u minus 2. And we can see that u minus 2 divides out. And we can now replace, there's nothing wrong now with replacing, substituting in 2 in for where u is. So let's do that. So we're going to have 2 plus 2, and we're going to have 2 squared plus 4. I'll just work left to right here to save some space. 4 times 8, this is going to be equal to 32. So the three main strategies we have: factor if you can, just generally good advice, period. Just factor. If you see something you can factor it. Factoring, I mentioned this in my last quick hits video. If factoring is a necessary skill that we should have in our math toolbox right now. Secondly, if you have an expression involving radicals, the square root of something, often rationalizing can help. And then finally, at times, especially when you're working with roots that aren't square roots, like a third root, fourth root, fifth root, using substitution is a method that can help you out. It can often turn an indeterminate limit into something that you could factor, like it did with our case here. All right, so this was a quick hits video reviewing the three methods for evaluating limits of indeterminate form, 0 over 0. We'll see you guys soon.